Okay, so now we have seen how the words can be arranged in the hierarchical fashion, and then see how it fits into the model that we discussed earlier. All right. So, we are going to be taking a neural network with 8 words as the vocabulary. Okay. So, I have given for refreshing your memory the architecture to the left, and then I have taken the nodes and the tree structure which we used earlier, and I computed the values as well, and they are found in the path. Okay. So, the idea is to we feed a value through the one hot vector, and then we need to compute the probability of the word W3, assuming that for the input word I need to find the probability of. So, this is what we are looking at, right. So, how do you really compute now, since the structure of the softmax layer is completely changed, and now the output layer does not really represent the words in that order. It just contains some values for 8 neurons. Okay. So, how do we map them? So, there is it is a slight trick here that we have to apply in order to use those output layer values and then update those changes in the context vector and the embedding vectors. Okay. All right. So, I have just shown here also as a graph, so that you will know what is the probability of each of the words which are distributed in the 8 word vocabulary. Okay. All right. So, now let us say that we have an input Wi, let us call it the input vector in a skipgram. We are taking a skipgram or CBOW. So, if you are going to be using a skipgram, so there is going to be only one input, and we are going to have multiple context words to be estimated, correct. And if you are going to be using a CBOW model, the input will have, let us say 4 or 5 context words. Okay. So, if you take the dot product of the embedding vector corresponding to that one hot vector value, you get the hidden value here, right. So, this we explained earlier. So, we have the hidden values, we have the context vector and then compute. So, we get some values in the output layer. So, as I mentioned earlier, this does not correspond to the word. Okay. So, how are we now going to update the weights if it is not going to be the word, if each one of the neuron is not corresponding to the word. Okay, let us now look at this. When you traverse from the root node to the second node, what you do is you first look at where it starts from. Okay. We always start from the root node, that is equal to 1, right. So, we assume that this node corresponds to the node in the output layer 1. So, instead of taking the softmax, we are going to be using a sigmoid. So, uj is nothing but right, this is where it is. So, here it is where you calculate each value. I am using this value as uj, not that index, okay, the value that is computed as uj. Okay. So, take the uj value from neuron 1, apply sigmoidal. What is a sigmoid? I am sure you will remember this, it is 1 by 1 plus e power minus x, right. So, applying the value of uj in this, you get a value, and then sigmoid is a function that translates the values of uj between 0 and 1, correct. The value would be between 0 and 1. So, when you have the value between 0 and 1, we call that as the probability of the node here. Okay. So, once this is computed, which is corresponding to the node in the output layer, and then we now go to node 2. So, what do? You take the value from here and then compute the value. So, this corresponds to the probability here. Okay. So, this is the relative probability of the word 3 or node 5, and then this is the relative probability of node 2, and then this is the relative probability of the leaf node. So, when we do that, what we also do is we compute this value, right. So, this is nothing but 1 minus right, got it. So, in this fashion we now have computed the probability of the word. So, we have shown earlier that by doing this we are creating a value W 3 which is normalized right across the vocabulary. So, once that is done, we have the value of W 3 which is the normalized value. And how do you now get back to the values here and then correct them. So, now we need to find out what is the error. So, since it does not correspond to any of the words directly, how do we take the decision? Let us look at that.